Welcome to the cast on distribution and data modeling. The content is developed by Jitendra Tomar, an academician and a corporate consultant, and is designed at JT Design Studio. Let us explore the concepts.
Have you ever felt like your favorite app just gets you? Like it knows what you want even before you do? Well, today we're pulling back the curtain on the invisible engine that makes all of that happen, data modeling. And trust me, it's less about scary math and way more about finding the hidden stories in the numbers all around us. Let's dive in. I mean, really think about it for a second. How does a streaming service just happen to recommend the exact movie you're in the mood for? Or how does a shopping site suggest that one thing you didn't even know you needed, but now you can't live without? It feels like magic, right? But it's not. The answer is actually something much more interesting. And that answer is data modeling. It's the secret sauce behind all of those incredibly smart predictions. At its heart, it's about building a kind of mathematical map of the real world, which lets us see all these amazing patterns that are completely invisible to the naked eye. Okay, so let's get right into it and start with the basics. What are we actually talking about when we say we model data? You can think of it like being a translator. Data modeling takes this huge, messy, chaotic jumble of raw numbers and turns it into a clear, structured story, a picture that actually explains what's going on and how things work. Now, to tell that story, we first have to understand the basic building blocks of our information. See, data isn't just a random cloud of points. It has a shape, a structure. You could even call it a kind of DNA. And in statistics, we call that a distribution. And that data usually comes in two main flavors. On one hand, you've got continuous data. These are things you measure, like your height or the temperature outside. They can take on any value within a range. But on the other hand, you have discrete data. These are things you count, like the number of times you click a button. You can have 3 clicks or 4 clicks, but you can't have 3.5 clicks. Knowing which one you're dealing with is absolutely crucial. All right, let's meet the absolute rock star of distributions, the normal distribution. You've definitely seen this one before. It's the famous bell curve, and it shows up pretty much everywhere in nature and data for a very good reason. What's so amazing about the bell curve is just how predictable it is. It's perfectly symmetrical, with the average value sitting smack dab in the middle. But the real magic is something called the empirical rule. It's a simple rule of thumb that tells us that about 68% of our data is going to be pretty close to the average. About 95% will be within a slightly wider range, and almost all of it, a whopping 99.7%, is going to fall within 3 standard steps of that average. And this is the perfect way to picture it. If you go out and measure the heights of thousands of people, or you look at their IQ scores, you're going to get this exact shape. Most folks will cluster right around the average, and you'll have very few people who are either extremely short or extremely tall. It's a natural pattern. Okay, but what if your data isn't a measurement on a scale? What if it's just a series of yes or no questions? Well, for that, we have the binomial distribution. Just think of it as the perfect tool for any heads or tails kind of situation. You really do see this everywhere once you start looking. Are you flipping a coin? That's binomial. Are you on an assembly line checking if a product is defective or not? That's binomial too. Or what about a simple survey where customers either prefer brand A or brand B? You got it. If there are 2 possible outcomes and a set number of trials, it's a job for the binomial distribution. So what if you're not counting successes versus failures, but you're just counting, well, how many times something happens? For that, we have the Poisson distribution. It is the perfect model for counting how many times an event occurs over a specific window of time or space, especially when those events are happening randomly. Think about a bank trying to figure out how many tellers they need. They'd model the number of customers arriving each hour, or think about the number of cars passing through a toll booth every minute. These are random events happening over a fixed period, and Poisson helps us understand and even predict how often they'll happen. So, we've got our shapes, our data DNA. We've got the bell curve, the yes-no model, and the arrival counter. The big question is, how do we use these to build something that's actually useful? Well, that brings us to the 3 main types of data modeling, which let us look at the past, understand the present, and try to predict the future. And it's a really logical journey. First, we look back to understand exactly what happened. Then, we use that to look forward and make an educated guess about what will happen. And finally, we figure out the best thing to do about it. The easiest way to remember this is to think about a visit to the doctor. So the first step is descriptive modeling. This is the doctor simply reviewing your medical history. It doesn't predict anything. It just summarizes all the past data to give you a crystal clear report of what went down. Questions like, what were our total sales last year? Or which of our products sold the best? It's all about what happened.
Then we move on to predictive modeling. Now, the doctor is looking at your history and giving you a prognosis. This is where we use all that past data to make our best guess about the future. For instance, which of our customers are most likely to cancel their subscription next month, or how much inventory should we order for the holidays?
And finally, we get to the most advanced and powerful stage, prescriptive modeling. This is the doctor actually writing you a prescription. It doesn't just tell you what's likely to happen, it tells you what you should do to get the best possible outcome. It recommends the optimal path forward.
Okay, I know this can all sound a little bit abstract, but I promise you, these models are running behind the scenes all around you all the time. So let's take a look at some of the places you bump into them every single day without even realizing it. Seriously, from the way you shop online to how your bank works to the way a package gets to your front door, data modeling is this invisible force that is constantly making the world around us just a little bit smarter and more efficient. You know that recommended for you list on your favorite shopping site? That is predictive modeling in its purest form. The algorithm analyzes your past clicks and purchases, compares it to thousands of other similar shoppers, and makes a pretty good guess about what you're going to want next. Or how about this? When a bank is deciding whether or not to give someone a loan, they aren't just guessing. They're using powerful predictive models that analyze tons of historical data to calculate the probability that the loan will be paid back. It's a classic example of using data to manage risk. And this is just the perfect example of prescriptive modeling in action. Your Map app doesn't just predict there will be traffic ahead. It analyzes all the possible routes in real time, and it prescribes the single best one for you to take right now. It's telling you what to do to get the best outcome. All right, so let's zoom out. We've covered a lot of ground. What's the one big idea you should take away from all of this? Why does understanding the basics of data modeling actually matter? I think it really boils down to three things. First, remember that data has a shape, and that shape tells a story. Second, modeling is the tool we use to read that story, to understand the past, predict the future, and make smarter choices. And maybe most importantly, this stuff isn't just theory for a textbook. It is the hidden architecture that powers the modern world you live in every single day. So the next time your phone suggests the perfect song or helps you dodge a traffic jam, you'll know the secret. You'll understand the blueprints that's working behind the scenes. And that just leaves one question. Now that you know how it works, what stories are waiting for you to find in the numbers all around you? Thanks for watching.